I plugged the numbers into the equation. Position in the y direction equals initial velocity times time plus half acceleration times time squared. There was no initial velocity in the y direction, so position equals half negative 9.8 meters per second squared times 5.23 seconds squared, and my answer was negative 134 meters. The negative was because it fell, so it was displaced 134 meters from the top of the building. And then in feet, I converted it to 439.63 feet. You go to Mars and learn its gravity is 2/3 of the Earth, so you test out your discovery on a pendulum. The length of the pendulum is 3.4 feet. What is the period of the pendulum? What would be its period on Earth? So the great equation to find out anything about a pendulum is period equals 2 pi times the square root of the length of the pendulum over gravity. And we have most of those. So gravity of Mars is 2/3 of Earth's, and Earth's is 9.8 meters per second squared. So just do the math, and it's 6.53 meters per second squared. And the length of the pendulum in meters, after I converted it, is 1.036 meters. The period we don't know, so we plug that into the equation, and the period of the pendulum in Mars is 2.5 seconds. Now we do the same for Earth, except for gravity, it wouldn't be 6.53 meters per second squared, it would be 9.8 meters per second squared. So we do the math, and the period on Earth of the pendulum is 2.04 seconds. A rocket was launched at the moon with the speed of 525 meters per second. 37 seconds later, its speed is 356 meters per second. At what rate does the rocket decelerate? Well, you have an initial velocity, a final velocity, and a time. So the only equation I can think of is the final velocity equals initial velocity plus acceleration times time. So since we want to find the acceleration rate, then I just changed the equation up a little bit, divided by time, subtracted initial velocity over time, and the new equation, acceleration equals final velocity over time minus initial velocity over time. I plugged in the values that I had from before and get an answer of negative 4.57 meters per second squared. The negative was because it decelerated, so I just wanted to make it clear that it wasn't accelerating, but it actually decreased in acceleration, negative acceleration. You launch a gummy bear from the ground with an initial velocity of 35 meters per second at an angle of 37 degrees. What's the horizontal velocity and vertical velocity? Well, to find that, I drew a triangle. I used my calculus skills, and SOHCAHTOA was really helpful. So the angle was 37 degrees, and the hypotenuse, which was what it was launched, 35 meters per second. And we want to find x and y. And to find the initial velocity for the horizontal, you use cosine adjacent over hypotenuse. And then you simplify the equation, and it's 35 times cosine 37. And the initial velocity in the horizontal direction is 27.95 meters per second. And you do the same for y, except since it's opposite over hypotenuse, it would be sine. So 35 times sine 37. And that was 21.06 meters per second. Part B, how long will it take the gummy bear to reach its maximum height? I use the equation final velocity equals initial velocity plus acceleration times time. There was no final velocity, so you plug in the numbers that we got from A and get the time of 2.15 seconds. And maximum height, you can also find that by using the peak time equation, which is the initial velocity in the y direction over gravity, and that was 2.15 seconds. Next, Alexandria had a force of 50 newtons, and Carla helped her, and her force was 5/3 of Alex's, and the table accelerated at 3 meters per second squared. So what was the mass of the table? Just use the equation F equals ma. But first we have to find out what Carla's force was, which was 5/3 of Alex's, and that was 25 newtons. Add them together, they're pushing parallel to each other, 40 newtons. The mass we don't know, and the acceleration is 3 meters per second squared. You just simply plug it in, and you get 13.33 kilograms. A helicopter has a mass of 1.7 times 10 to the 5th kilograms. How much force generated by the engines must be exerted to obtain an acceleration of 2.89 times 10 to the 5th meters per second squared? Well, just do the same thing. You have the equation F equals ma. You know what the mass is. You know what acceleration is. You're just looking for force. So you multiply them and get 4.913 times 10 to the 10th newtons. And, okay. Danny's playing basketball and he wanted to score, so he threw the basketball with all his might. Unfortunately, Danny only hit the backboard. The ball flew back to Danny and past him. The ball traveled 7 feet to the basketball hoop when Danny threw it and ended up with a position of 3.35 meters relative to where he stood, so negative. How long did it take for the basketball to reach the ground? At what final velocity was the ball traveling vertically? So first we want to convert everything in feet to meters. And 7 feet, which was how far away he was from the hoop, was 2.13 meters. And since the ball went to the hoop, that's where it traveled. And then it also came back and passed that position. So you multiply it by 2 because you need 2 times the distance, which is what it traveled, as this drawing shows. And then you want to add it to how far, where he ended up. Relative to his position, it was 3.35 meters past where Danny stood, so you just add those numbers together, and the total displacement of Danny's basketball was 7.61 meters. And we want to find the final velocity. Oh, we want to find the time first, so we can find the final velocity. So we use the equation position equals half at squared, and that would be t equals 1.24 seconds. And then, since we have time, now we can find the final velocity. Final velocity equals initial velocity plus acceleration times time. Plug in the values, and it is 12.15 meters per second. A motorcycle accelerates at the rate of 13 meters per second for 7 seconds. If the motorcycle traveled 283 meters, what was the motorcycle's initial velocity? So here are the constants. And then we want to know the initial velocity, so there's a couple of equations, but this was the one that popped out. Position equals initial velocity times time plus half at squared. You don't know initial velocity, but you know everything else. So we plug in these values and find an initial velocity of 6.13 meters per second. Now fill in the table based on the position time graph below. So what happened was I drew the position versus time graph, and I left the writing in pencil blank, and you would have to guess, you would have to calculate what these answers would be based on this and the graph. Major was on a ride called the wheelie, which spun around in one circle every 4.7 seconds. He was 40 feet away from the center of the wheelie, which controlled the ride. What was its centripetal acceleration? So the equation for centripetal acceleration is 4 pi squared r over t squared. r, the radius of the circle, would be 40 feet. We want to convert 40 feet into meters so it will be easier to work with, and that is 12.192 meters, and then the time is 4.7 seconds. So we plug it into the equation, and the centripetal acceleration is 21.79 meters per second. Janine was mad at her little sister Danielle, so she tied Danielle's feet to the end of a tetherball string attached to a pole and gives her a good spin. Janine records 5 moments at 0.19 second intervals and measured the arc that Danielle moved through in that time, which was 176 degrees. The radius of the circle that Danielle and the string created was 5 foot by 1 inch and 0.3 meters. What was Danielle's centripetal acceleration? Now, I wrote this kind of funky because I started out the sentence, I was just going to add them together, but I wanted to make it more difficult, so I separated the radius of the string and the height of Danielle. So we have to convert her height into meters first, and then we add them together like so, and the radius is a total of 1.8494 meters. And the period, to find that out, a complete circle is 360 degrees, and this arc wasn't a complete circle, so we divide it by how many degrees that was and multiply it by the number of seconds for all the intervals, which were 5 intervals. So you multiply 5 times 0.19 seconds, and that's 0.95 seconds, so you multiply those two values together and get 1.94 seconds for the period. Plug those values into the centripetal acceleration equation and get 19.4 meters per second squared equals the acceleration. In a speed of sound experiment, the distance to the reflecting wall was 73 meters. The travel time of the sound of the echo of the claps was 18 seconds for 45 sound bursts. What was the speed of sound if it were 37 degrees Celsius?